class. I welcome you all to the environmental chemistry practical class. In environmental chemistry practical class, we generally study various testing methods for water quality parameters like acidity, alkalinity, presence of chloride ions, dissolved oxygen, total dissolved solids, total solids, etc. So among these experiments, I am starting here with the test for alkalinity in a given water sample. So how will you determine the alkalinity of a given sample of water? Alkalinity is basically defined as a measure of the capacity of a given water sample to neutralize acids. So it is the capacity to neutralize acids, and it is basically due to the presence of different types of anions such as hydroxide anions, or you can say hydroxide ions, carbonate ions, and bicarbonate ions. It is basically divided into two categories. One is known as phenolphthalein alkalinity. Alkalinity, while the other is known as total alkalinity. While phenolphthalein alkalinity is due to the presence of hydroxyl ions, total alkalinity is due to the collective presence of hydroxyl, carbonate, as well as bicarbonate and other ions. So therefore total alkalinity comprises of phenolphthalein alkalinity as well as alkalinity due to other types of ions. High alkalinity shows that the given water sample has higher concentration of these anions. Now, the alkalinity of the sample is determined by titrating it against an acid. Generally, HCl or H2SO4 is used for titrating the sample for alkalinity determination. What we do is, it is basically a two-step process. First, we take a water sample and put few drops of phenolphthalein. As you know, phenolphthalein is an indicator which gives pink color at pH 10. So if hydroxyl ions are there, it will turn into pink color immediately after adding few drops of phenolphthalein. Then we have to titrate it with HCl. In this experiment, we take 0.02 normal HCl, and the point where that pink color disappears is the end point for first case, and we measure the volume of HCl. That volume of HCl is basically used to neutralize phenolphthalein alkalinity, means the alkalinity due to hydroxide ion only. Then again we add few drops of methyl orange to the same solution in which we already added phenolphthalein and titrated with HCl. So we again added to that same solution few drops of methyl orange. The solution becomes yellow color, and then we again titrate it with HCl, continuing the titration from the point where we left it in case of phenolphthalein alkalinity, and this time we will continue the titration till the yellow color changes to orange color. Clear? And then we note down the reading. This time we note down the total volume, the volume consumed for phenolphthalein alkalinity as well as the volume consumed for total alkalinity. So the volume from 0 till when the solution becomes orange color. The total volume will be used for calculating total alkalinity, while the volume of HCl, that is only used for disappearance of pink color of phenolphthalein, that will be used for calculating the phenolphthalein alkalinity. Clear? I'll also show you how the experiment can be done, how the experiment happens. And for every sample, we take 3 readings for phenolphthalein alkalinity and 3 readings for methyl orange, and then we take the nearest 2 readings and do their average. Then that value is used in the formula. Clear? I hope you got the point, and then I will show you how we can do the experiment. So the procedure is, First of all, we will take 50 ml of the given water sample and add few drops of phenolphthalein indicator so that the solution becomes pink in color. This shows that the solution or the given water sample has OH alkalinity due to hydroxide. Then we titrate that pink color solution till the color disappears. We note down that reading as V1. Then we again add few drops of methyl orange. Now after adding methyl orange, the solution turns yellow color. Then that yellow color solution will again titrate it from the same value. We do not again set it to 0 and we titrate it with HCl again so that the yellow color changes to orange color. We note down this reading as V2. Now the calculations will be as follows. For phenolphthalein alkalinity, of course, as you all know that alkalinity is always reported in milligrams per liter of CaCO3 equivalent, calcium carbonate equivalent. So for phenolphthalein alkalinity, we take V1, we will multiply it. V1 is the total volume of HCl consumed with, in the first case when phenolphthalein was added, the total volume of HCl when pink color disappeared, that V1 multiplied with the normality of HCl, which is 0.02 in present case, multiplied by 50,000 divided by V. V is the volume of sample in ml. This will give us the phenolphthalein alkalinity. While for calculating the total alkalinity in milligrams per liter of CaCO3, we will take the total volume, including the volume that is consumed for disappearance of pink color, plus the volume consumed for conversion of the transformation of yellow color to orange color. That total volume will be placed here as V2 multiplied with the normality of HCl, that is 0.02 normal in present case, multiplied by 50,000 divided by the volume of the sample, which is 50 ml in present case. This will give us the total alkalinity. Total alkalinity includes the phenolphthalein alkalinity as well. And as I told you in this lecture, start of this lecture, that phenolphthalein alkalinity is because of hydroxyl while total alkalinity includes the alkalinity for hydroxyl as well as for carbonate and bicarbonate. So now we will see how the experiment can be done. So this is our duet having HCl of 0.02 normal concentration. These are our sample 1 and sample 2. This sample contains the given water sample, which is 50 ml in volume. So first of all, as per the procedure, we will add phenolphthalein, few drops of phenolphthalein into this solution. Now you can see the solution is pink in color. White paper is basically used to just to check the color difference. Now we start adding HCl. Now you can see the solution again becomes colorless. So, and the reading is 2.5. So V1 in our case is 2.5 ml. We'll try to add few drops of methyl orange indicator. Now the solution becomes yellow in color. We titrate it again till this yellow color becomes orange. So this is the end point of the experiment. We again note down the reading. Now it is 4.2. Earlier it was 2.5 ml. So V1 in our case is 2.5, while V2 is the total volume 4.2 ml. So applying the formula and putting these values, phenolphthalein alkalinity is equal to 2.5 multiplied by 0.02 into 50,000 divided by 50, we get 50 milligrams per liter of CaCO3. The alkalinity of phenolphthalein alkalinity of the given sample is 50 milligrams per liter CaCO3 equivalent, while total alkalinity V, applying the same formula for total alkalinity, V2 is 4.2 multiplied by 0.02 multiplied by 50,000 and divided by the 50 ml, 50 which is the volume of sample, we get 84 milligrams per liter of CaCO3. So this is the total alkalinity and phenolphthalein alkalinity of a given sample, and total alkalinity is always greater than the phenolphthalein alkalinity. I hope you got the point.